Okay, so remember, our goal is to say, for example, I want to know what is the true population averages. Okay, so I went out and I collect a sample. And using this sample data, I can apply to it hundreds of different estimators. Okay, the question is, how do I know which estimator is good or which estimator is bad? Right? And as I said before, right, the one we will use most, we will always use now is x bar, right, which is simply the summation of xi, right, divided by n. But why is this a good estimator? Okay, so there's a couple characteristics that we will focus on. Right? First one is unbiased. Okay, x bar is unbiased. What does unbiased mean? Unbiased just means the average value of the estimator equal to the population parameter being estimated. Suppose that I go out and collect a sample of 25 people. Okay, and so today I do it. So today I can go out collect 25 people, and I'm going to get an x bar 1. Okay, and let's say that value is 12. Okay, tomorrow I go out and get another sample of 25 people, and tomorrow I'll go out and maybe I calculate 23, and I'll do it again, and maybe again another different group of 25 people, and then my sample is 15, right, and so on. Now remember, my goal is to estimate the true population average. I have no idea what this actually is. Okay, but when I use x bar, I can trust that on average, right? If I take all the sample, right? If I take all of the sample x bars, and then take all the average and add it up, and then divided by how many times I have that, then this will equal the population average, right? Is that this is a good estimator. This is an unbiased estimator because on average, right, I am expecting that I will see a mu. Okay, and if I write this out mathematically, is that the expected value of x bar will equal mu. Right, the expected value of the estimator right, equals to the true population, the population parameter. Okay, all right, and if this is true, and again, if you guys move on to higher levels probability courses, you will actually prove this mathematically. Okay, but for now, right, we can just take this as given. We can accept the fact that x bar is unbiased, and so you have to know just what is the definition of being unbiased. The second quality of an estimator that we will talk about is the mean square error. Okay, that means the expected deviation of the estimator from the true population parameter. Mathematically, it looks like this. Expected value of, let's say, x bar minus mu squared. Okay, you will never have to calculate this, but I just want you to understand the idea of it. It just means that on average, how far is the estimate off by? Right? What is the deviate? What is the deviation of the estimate? Okay, so I think a visual will help. Let's take, for example, right? Let's take these targets that we looked at, and let's imagine that these targets are by different shooting instructors. So imagine that you are following the instruction of the shooting instructor, and these are the results. Okay, so we will say, right, target 1 and 2 is unbiased, whereas target 3 and 4 is biased. Why? Because the goal is to get the bullseye, but it seems like there's a drift. Right? Target 3 and 4, even though, like say target 4, it seems very accurate, but it's not aiming at the bullseye. Okay. Now between 1 and 2, right, the mean square error for 1 is going to be much higher than 2. right? Because you have, even though target 1 on average, right, is going to be at the bullseye, but the deviation, right, each estimate, right, think of each shot as an estimate. Each estimate is further, it deviates very far away, whereas 2, right, they're all very close. Right? The mean square error for for 3, right, actually 3 and 4, the mean square error for 3 and 4 is actually smaller than target 1. But however, because target 1 is unbiased, we would still prefer target 1 over target 3 and target 4. Target 3 and target 4, right? The deviation, so you want to visualize is how far is each shot away from the bullseye. Okay, and 4 clearly has a smaller mean square error, and in fact, it might actually have a smaller mean square error than target 2. Okay, but we will still prefer target 2. Right? So rules for picking estimators. Okay, so first rule, right? You always use unbiased estimator. Why? Because on average, right? Then if we're using unbiased estimators, on average, we can expect to get the true population parameter. Right? If we use a bias estimator, even though it might actually have a very small deviation, but we can never trust it. We can never know if we are actually getting the true value. Okay. Then second, use the one with lower MSE, mean square error, right? Of course, we use the one with the smaller deviation.